These are both ionic compounds. What do we know about the charge on A and the charge on C?
Oh, positive.
Can A go with C?
No.
We might be swingers,
Yeah.
but we still gotta go with an opposite.
Wouldn't that be like 2 girls?
Yeah. You can't have 2 girls and 2 guys together.
Chemistry is not PC.
Yeah, chemistry is not PC, right? They might be swingers, but they gotta go with someone of the opposite gender. Positive's gotta go with negative. Y'all never knew chemistry could be this much fun, did you? See, you learn about all kinds of social stuff in here.
This is the same thing with single replacement too, right?
Yeah, exactly. If you're a metal and a single replacement, you gotta go with a non-metal. You can't have 2 metals together, right? Very good. Someone's paying attention.
So you can't have 2 non-metals together.
You can have 2 non-metals, right? They form covalent compounds. They're not talking about charge at that point, right? Because they're not charged. They're not positive, negative anymore.
Right.
Only ionic compounds have positive, negative, right? Metals and non-metals are polyatomic ions. That's a different situation, right? Here we have all ionic compounds. Well, except for this one. But in this case, right, we're going to break it apart. So zinc, so sulfur can't go with chloride. Just can't happen.
Right.
Okay.
Right? So zinc's going to go with chloride, and sulfur goes with hydrogen. They form this covalent compound, and it's a gas. And they leave. They split, right? They bubble. If you do this, it produces hydrogen sulfide gas. It bubbles. If you do this one, what happens? This is a reaction I asked you guys to write earlier, isn't it? Anybody recognize that? You see a solid. It's a white solid. It settles out. Really strong, right? That's why it forms. It settles out. Okay? So what do we have? Combination reactions. 2 things come together to make 1. What happens to that? Decomposing, 2 things break apart to make 2 separate things, right? A couple breaks apart. What might happen? 2 plus 1, single replacement, go kick somebody to the curb, or 2 and 2, our modern progressive reaction, right? Go do wife swap. Okay?
Husband swap.
Or husband swap. Depends upon your point of view, right? There is a TV show called Wife Swap. There's not one called Husband Swap.
Yeah.
I watched that the other day. It was awful. Oh my God, it was bad.
It just sounds better if it's her idea.
Whew. All right. In a combustion reaction, a combustion reaction is a little bit different. The products of a combustion reaction are always water and carbon dioxide, okay? Carbon dioxide and water, and normally lots of energy. Who's ever done a combustion reaction before? Who's ever burned something before? You go down to the fire pit? That's a combustion reaction, isn't it? You're actually producing, most of the products that you're producing are carbon dioxide gas and water vapor. There's a little bit of ash left at the end that didn't burn totally, didn't combust.
I was going to say,
But-
start your car.
When you start your car, you are combusting the gasoline.
So what about spontaneous combustion?
Doesn't exist.
It does not.
No.
So that's almost
Argue
like
that.
cellular respiration.
Cellular respiration is combustion. It is sugar plus oxygen to produce CO2 and water. Cellular respiration is absolutely a combustion. That's why when you exercise, your body gets hot and your internal temperature goes up because you're burning sugar. That's why your body has to have a mechanism to keep it cool, right? Because you're burning stuff. Got a little fire going in you. Fire in your belly. Right? Actually, it's a fire in every cell. Because all your cells are respiring, burning sugar to do the stuff they need to do. And when you're exercising, it's your muscles are burning lots of sugar, right? Okay? So, these are organic compounds. This one is called methane, and this one's called propane. Who's ever burned methane before? Where do you find methane at? It's natural gas. So if you have a gas stove, or in the lab if you used a Bunsen burner, where do you find propane?
Gas
Same thing.
Gas grill, or or some people have big propane tanks to run their heater or their stove or something, right? So most of you've seen these before.
I thought you were gonna say methane was, human gas.
It actually does contain a lot of methane. Actually, the two biggest sources for methane in the world are cow flatulence and termite mounds.
Yeah.
All right, I want you to balance two more problems for me. I'm gonna leave the states off. Actually, I'm gonna help you balance these because we don't have time to do them. If you guys will write these down, then we're gonna balance them together. Okay? My twos look really bad as well. Okay. Are we ready? We've got them both written down?
Yeah.
Let's do the second one first. It's easier. Well, I'm going to stand up just a second. Give me a chance. All right, let's do the second one. How many carbons on the reactant side? And on the product side? So we're going to fix it, right? Put a 5 there. How many hydrogens on the reactant side? 12. And on the product side? So to make 2 and a 12, we put a 6 here. How many oxygens on the reactant side? 2. And on the product side? 6. So how do we fix that? Put a 3 here. Okay? I think all the practice we have, most of y'all get this one, right? Y'all pretty good?
Only this one part where you said the C and the 5 to start with. How come the CO together is not a poly?
No.
Okay, that's
This
fine.
is carbon dioxide. 2 nonmetals. There's no charge on it.
Then I understand.
Okay?
Maybe carbon.
All right, this one's a little bit harder. Let's start on it. How many carbons? 4. So we're going to put a 4 over here. How many hydrogens? 10. And over here? So what do we do? 5. Oxygen. We have 2 over here. And how many do we have over here? We have 4 times 2 is 8. Plus we have 5 over here, don't we? So we have 13. So we have 2 on the reactant side and 13 over here. Oh dear.
I see.
What do we do?
How'd you have 13?
I have 4 times 2 is 8.
Okay, and 5.
And then there's 5 from here, so that gives me 13, right? Watch this. I'm going to ignore this for right now. This O2, I'm going to ignore. And I'm just going to go 2 here, 8, 10. Probably should have written that in a different color. 8 and 10. Okay? Let's go back and look at our carbons. 2 times 4 is 8, and we have 8 here. Hydrogen, 2 times 10 is 20, and 10 times 2 is 20. So we didn't change carbon and hydrogen, really. We just doubled it. Look at our oxygens now. How many oxygens do I have here right now? 8 times 2, I have 16. And how many do I have here? I have 10. So now I have 26.
13.
So now I put a 13 right here.
Hard.
That one's hard, right? This, if you can do this one no problem, that's like a C. If you can do this one with no problem, that's an A. Right? Because that one's tough. That one's harder. Okay? See the difference in level of difficulty. Question?